Alright guys, today we're going to look at solving systems of equations by elimination. We've already looked at how to solve systems with graphing, where you graph the two lines and see where they cross. We've also looked at substitution, which we're going to recap right now. That was our first algebraic way of doing it. So let's look at another algebraic way. We're going to look at another algebraic way today. But first, let's recap solving by substitution. Solve this first system by substitution, pause, and come back. Alright, I'm solving for this y. You may have done it differently. If you did, good for you. Okay, we should get the same answers anyway. Subtract 3x from both sides, and you get negative y equals 4 minus 3x. Then divide everything by negative 1, and you get y equals negative 4 plus 3x. Okay? Plug that back into the other equation. Again, you're going to write everything exactly the same except where the y is supposed to go. See, everything's there except where the y is supposed to go, you stick what it is in terms of x in parentheses. All we got to do now is just kind of plug in, and we get 2x minus 16 plus 12x equals 8. I'm going to combine my like terms and add 16 to both sides. I get 24 over here. This one's a little bit awkward because we don't get a nice whole number. We get a fraction. We get 12/7. Okay, but guess what? That's not really a big deal because we can deal with fractions. So now we go back to where we had y equals negative 4 plus 3x. We take out the x, and we write 12 over 7. And we could probably at this point just type negative 4 plus 3 times 12 over 7 into our calculator, and it would give us an answer, and we could have our calculator make it into a fraction for us. I prefer to do it by hand. So I get 36/7 when I multiply 3 times that fraction. In converting negative 4 into sevenths, I get negative 28/7. Add those together, and I get y equals 8/7. So we got two fraction answers. Fractions are fun. I prefer fractions over decimals because decimals we often round and then they're not really exact answers. So, for elimination, we have two essential questions. Can we add two true equations together? And I guess what I should have added to that is, can we add two true equations together and still get something true? And can we multiply all terms in an equation by a constant and still get something true? Okay, so pause and think about those for a second. Okay, hopefully you took time to pause and think about those. The answer to both is yes. The answer to both is yes. And we could make very easy illustrations as to why. I'm just going to write two equations without variables that I know are true. Oops. There we go. And the question was, could I add them both together and still get something true? Well, if I add them like straight down in columns, like if I kind of said I'm going to add this, I'm going to add this, I'm going to add this, well, I'd get 6 plus 5 equals 11. This was true, the bottom is still true. Same thing for the constant. I could come up with a really easy illustration. If I start with 1 plus 2 equals 3, and I multiply everything by 5, I get 5 plus 10 equals 15. The original was still true, the new is still true. So now that we know that we can add equations together if we feel like it, and we can multiply them by a constant if we feel like it and not change the fact that they're still true, we're going to utilize that strategy to help us solve systems of equations using a process called elimination. Okay, so I'm going to explain these steps very quickly, and then I'm just going to jump right into it. So what we're going to do initially is we're going to use that idea that we can multiply by a constant. Now, we may not need to use it at all, or we might need to use it on one or both equations. What we're trying to get is a situation where we want opposite coefficients on one of our variables. So what we want is something that looks like this in our system of equations. Negative 4x plus 6y equals 2. 4x plus 7y equals 11. We want this situation right here, a negative 4x and a 4x. Those are opposite numbers, opposite coefficients on our x's. Okay, that's the first thing you have to do. Once you do that, the rest is pretty easy. Add the equations together, solve for a variable, plug in, solve again. Okay, it'll be very similar to substitution at that point, the process of finishing things up. Okay, so I'm going to jump right into it. Some of these steps probably don't make sense right now, and that's definitely okay. So looking here, I need opposite coefficients. My eye is immediately drawn to the y's because they already have opposite symbols, a positive 2 and a negative 4. I just need them to be opposite numbers. Well, I know I can turn a 2 into a 4 by multiplying by 2, so I'm going to multiply just my top equation by 2. My bottom equation I'm going to leave alone. So when I multiply my top equation by 2 to get another true equation, this is what I get. And my bottom equation stays the same. I have achieved what I wanted to achieve. I wanted those nice opposite coefficients. I got them. And we're going to find out why right now that I wanted those. I'm now supposed to add these two equations together. Well, you can only add like terms, so adding 6x and 5x gets me 11x. Adding 14 and negative 3 gets me 11. Well, and adding 4y and negative 4y gets me 0. That's why I don't need to write that. Okay, so that's why I wanted the opposite coefficients, because then when I add them together, they go to 0. Now I can solve this equation. It's one equation, one variable. Just divide by 11, and I get x equals 1. You can literally put that x equals 1 anywhere you want. You just need to put it somewhere where there's both an x and a y. Okay, so I'm going to put it into my original top equation, and put it into this one. And I'm going to write 3 times x, which is 1, we know that now, plus 2y equals 7. And again, you can show as much work as you like here. I'm going to jump to the thrilling conclusion that y is equal to 2. And you should check your answer by plugging it into both equations, but you'll find that x equals 1 and y equals 2 works for both. So you're going to try the next two on your own. The big difference is that you're probably going to have to multiply each equation by a number as opposed to just one of them. So try the next two problems, pause, and then come back. Okay, so this one, again, my eyes are still drawn to the y's. You may have seen x's because they look like smaller numbers, but I know that I can get 6 and 4 to match at 12. I don't have to go all the way to 24. So multiply this one by 2 and this one by 3 because I already have a positive and a negative. Okay, and I get 8x plus 12y equals 84, and 9x minus 12y equals negative 33. I got my opposite coefficients. Add them together. 17x plus 0 equals 51. Divide both sides by 17, and I get x equals 3. If you eliminated x's, that's okay. If you eliminated by multiplying by 4 and 6 to get rid of your y's still, that would have turned out okay too. You still would have gotten x equals 3. If you got y first, you're about to find out what you should have gotten. So now, I'm going to plug back into my original top one. 4 times 3 plus 6y equals 42. 4 times 3 is 12, so I'll subtract 12 from both sides. 6y is 30. I get y is 5. And again, you can check your answers. It works for both. Last one. This time I'm going to get rid of x's, not because it's easier, but because I want you to see what happens if in a situation where you don't have a positive and a negative on one of your variables. If I were to really want to get rid of x's, the problem is they're both positive, so I can't just multiply by 5 and 6. That'll get them both to 30, but I need one of them to be 30 and one of them to be negative 30. So what I'm going to do instead is I'm going to multiply the top one by negative 5. Okay? So that's going to make all of this stuff in here negative, because it was all positive before. And the bottom, those signs aren't going to switch. And 19 times 6 is 114. Okay, so over here we get 54. Over here we get negative 27y, and our x's cancel out. Divide by negative 27. We get y is equal to negative 2. Plug in somewhere, it doesn't really matter where. I'm gonna plug into the top one, so I get 6x plus 3 times negative 2 equals 12. 3 times negative 2 is negative 6, so that means I need to add 6 to both sides. And I get 6x equals 18, which means x is 3. And again, I could check both of these answers, but it'll definitely work in both. Okay, that's it for solving systems by elimination. The big keys are, I guess, don't forget to multiply all 3 terms by a constant when you're choosing to do that. And also don't forget to that you can multiply by a negative if you need to get those signs opposites. That's it for this one.